Okay, all right, so we've started the recording. So for recording purposes, I'll go through and I'll say what I just said is that we are recording this. I'll be emailing a link to the recording out to everybody after the review is over. And that way you can, watch it at a time that's more convenient for you or rewatch problems that you want to see again, that sort of thing. So my name is Maxine. I work at the Academic Support Center. You can either email me directly. Technically, my first name is Brandy. That's why that email address is showing that way, but you can also email me at maxine.horn@daytonastate.edu. I'll also be sending out information about, how to how to look up the hours of operation for your academic support center at whatever campus you're closest to, and the times that I am at different campuses. So this is just one resource that you guys have is these reviews. Another resource is, of course, your instructors, and then also the tutors and learning specialists at the academic support centers. So for these reviews, what we're going to be doing is, you know how you guys have a review homework that you have to do before the test? It's kind of like a summary of everything that's going to be on the test. That's what these reviews are going to be, is we're just going to go through the set of problems that you guys have to do for the review. The questions that I have are going to be slightly different than the questions that you'll have on your homework assignments, but we're just going to go through and we're going to do all of them. I know that the review was set to be, I think we say it's like 1 hour. I'll be honest, they're more than an hour. So if you need to leave partway through, or, if you ever can't attend, no worries, that's fine. We know people's schedules can be difficult. So yeah, no worries if you have to leave partway through. I'll be sending you the link and you can watch when it's convenient for you. All right, so we are going to dive right in. So these chapters are a lot of, as you would imagine, introductory things, right? A lot of definitions and things like that. So a lot of the ones that we're going to be going through are just, hey, this is the definition. This is what this means. So number one, how is a sample related to a population? A sample is a subset of a population. So some of the symbols that you guys are going to need to know, like in your calculator, and my pencil is, there we go. So in your calculator, not for this particular question, but later on in this chapter, you have mean and you have standard deviation. So for the sample is a different symbol than for the population. So your sample mean is X with a bar. We literally just say X bar. And for population, it's this little thing there, which is the Greek mu. For standard deviation in the calculator, it's S, or you might see S with a sub X. And for population, it is this symbol, which is sigma. So you guys will need to know that at some point, and then definitely for in your calculator, you need to know that S is your sample standard deviation. Okay, so a sample is a subset of a population. Number two, what is the, oh, and also I'm sorry if I didn't mention this, but if you have any questions as I'm going, feel free to, let me admit this person. Okay. All right, so yeah, feel free to either type it in the chat, is probably going to be the best way to do it, or you can either raise your hand, or you can unmute yourself if you need to ask a question kind of as we're going. Okay, so what is the difference between a parameter and a statistic? So a parameter is a numerical description of a population characteristic. A statistic is a numerical description of a sample characteristic. So an easy way to remember that is that you have a population parameter, because they both start with P, and you have a sample statistic, because they both start with S. So that's a nice, easy way to remember that. Okay, number 3, determine whether the data set is a population or a sample. Explain your reasoning. The number of floors in 8 buildings in a city. So this is a sample because it's a collection of the number of floors for some buildings in the city. So it's only 8 buildings in the city. Well, there's a lot more than 8 buildings in a city. We're only looking at 8 of them. So that's just a part. It's just a sample of the whole population. Okay. All right. A survey of 1,500 US adults found that 58.6% have never had a vaccine reaction. Identify the population and the sample. Describe the sample data set. So this is a survey of just 1,500 what? US adults. So not all US adults, but just 1,500 of them. So the whole population, this is just a sample of the whole population. The whole population is all US adults, or the responses of all US adults. So well, and that kind of answers the next question, right? The sample is the 1,500 US adults, or the responses of the 1,500 US adults that were selected. And then you'll see the same type of wording in all of these when they ask you to describe the sample set. They want you to, so they've given us one part of this. So we've got 1,500 people, okay, and they're saying 58.6, so a little bit more than half. So 58.6% of them have never had a vaccine reaction, but that's just describing one part of this sample. We need to also describe the other part of this sample. So we want to give them this percentage. So remember, when talking about percentages, it's out of 100, right? So we're going to do, okay, 100% minus 58.6%. That's what's going to give us the 41.4% that describes the rest of this sample. So 58.6% of the 1,500 US adults who have never had a vaccine reaction, and 41.4% of the 1,500 US adults who have had a vaccine reaction. Okay, so remember, percentages, it's out of 100. So you can just, if they give you one, you can subtract it from 100 to get the other one. All right, identify the data set's level of measurement. Okay, so in your book or your online book, it gives you a table that talks about what these different levels are. So to just kind of summarize it, is that if you can arrange the data in categories, that is nominal. So I'm going to kind of go in order here. So you can think of nominal as like name, nominal name, the names of the categories. If you can arrange in order, so you can put it in order, then that's ordinal, right? Order sounds like ordinal, hopefully a little bit easier to remember. If you have something that's like a ranking, that's ordinal. And then if you can find meaningful differences meaning subtraction, and meaningful in that it's actually helpful. It's not just, oh, I was given 2 numbers, I can subtract any 2 numbers. Okay, but when I subtract them, do I find something that's meaningful, that's useful? That would be interval. So the types of things that are interval are things like degrees, like when we talk about temperature, or scores, like in games, or years. Things like that are often interval. And then if you can find meaningful ratios, then you are ratio. make sure that that's interval. That's ranking. So these, I feel like the names are a little bit easier to remember because, sorry, my pencil has run out of lead. All right, let me go get another pencil real quick. So yeah, having this kind of memorized or making sure that it makes sense to you will help with these types of problems. All right, let's see. Okay, this one's got lead. Okay, so that's why the ages of students in a stats class are ratio, right? So we can find meaningful ratios. The temperatures of 18 selected refrigerators. So temperature, that's a degree temperature. So that's going to be interval. And then, I'm sorry, move this so we can still see that. The list of social security numbers is nominal. Okay, so if some of these don't necessarily make sense to you, I mean, ideally, you're going to want to understand it so that they make sense so that you could pick out what the answer is for any of these. But if you're finding that it's not really intuitive for you, then might be a good idea to literally just write down, okay, wait, if I'm given a degree, I know that's interval. If I'm given a score, I know that's interval. If I'm looking at a year, I know that's interval. If I'm looking at a ranking, I know that's ordinal. Just kind of make a list of the types of problems you've been given, of what you're being given, and assign them to each one and memorize that list. So that's one way to do it if this is not really intuitive for you. The ratings of a movie ranging from poor to good to excellent. So ordinal. So again, we're just kind of looking at, so we can arrange them in order. You might think, oh, category, those are different categories, right? Poor, good, excellent. Yes, but then you can put those categories in order. So that's why it gets bumped up to ordinal. All right, determine whether the data set are qualitative or quantitative. So quantitative, like quantity, that's going to be a number. Qualitative, like quality, that's going to be like a category, a quality, something that is not, that you can't assign a number to. So the colors of automobiles, that's a quality, not a quantity. Quality. Determine whether the data are qualitative or quantitative. The number of seats in a movie theater. They're literally using the word number. That's why we know that it is quantitative, because it's a number. Okay. And again, if I'm kind of going too fast through these, I'm going to be emailing you the link to the recording so that you can just kind of pause it and kind of think through each one. We've got, I think, what is it, 36 questions to go through, something like that. So we we want to try and get through them all without going too far beyond the hour mark. Okay, determine if the survey question is biased. If the question is biased, suggest a better wording. So when we're looking at survey questions and being biased or not, you want to be asking, is the question telling me something? Like, not just is it asking me something, but is it telling me something? So why is drinking soda bad for you? Well, that's telling me that drinking soda is bad for me. So it's telling me. So I'm going to write that out. Is the question telling me something? An unbiased question is not going to provide you with information. It's going to be asking you for the information. So it is telling us something. It's telling us that soda is bad for us. So the question is biased. The wording, how do you think drinking soda affects your health, would be better. So it's not even telling us that it affects our health. It's asking us how we think it would. Like, well, actually, you could argue for, a little bit of different wording there, but an answer to that question could be, I don't think it affects my health at all. Or you could say, I think it's bad for me, or I think it's good for me, right? So you could answer that question without being influenced by them telling you that it is bad for you. Similar question down here. How much do you sleep per night during an average month? So they're not telling you something. They're not telling you, oh, you need to be sleeping 8 hours a night. And how is your less than 8 hours of sleep a night affecting your health? They're not telling you anything. They're just asking what, what your average sleep per night is. So it doesn't lead to any particular answer. They're not guiding you to a particular answer. All right, use the given frequency distribution to find a bunch of stuff. The class width, the class midpoint of the first class, and the class boundaries of the first class. Okay, so let's talk about a few definitions here. So a lot of times people get confused with boundaries and classes. So when you're looking at a frequency distribution, these numbers in, oh, sorry, you can't see that. These numbers in this column right here are your lower class limits. Okay. That's what all of these numbers are. The numbers over here are your upper class limits. It's an E. Okay, these are your upper class limits. This is one class. This is the frequency that corresponds to that class. So classes do not overlap, right? They do not overlap. Sorry, there we go. So let's answer the first one before we move on to midpoints and boundaries. So the class width. So a lot of times people will get confused thinking that they need to be looking at one class to find the class width, but the class width is actually what you have to add to one either lower class limit or upper class limit to get to the next either lower class limit or upper class limit. So what I mean by that is, what do I have to add to 135 to get to 140? Or I could say, what do I have to add to 149 to get to 154? So it can be from the first to the second class or the third to the fourth. It can be from whichever class you want to the very next class, and you can either be looking at your lower class limits or you can be looking at your upper class limits, but you're going to get the same thing every time. So we say, what do I have to add to this to get this? If I wanted to, I could real quick just do that math. 140 minus 135, that's going to give me 5. So my class width is 5. And you can check yourself by saying, okay, well, then that means that I would need to add 5 at each class to get to the next class limit, either the upper or the lower class limit, right? That's what that means. Okay. All right, so that's our class width. All right, the class midpoint of the first class. So the class midpoint is the point that is midway between these two. So you can kind of think of it as like the average of these, right? Because that's actually how we're going to find it, right? We're going to add these up and divide by 2. So we're going to go 135 plus 139 divided by 2. Quick note here for the calculator. You always want to make sure that you never get a question wrong because you accidentally plugged it in wrong to the calculator. There's 2 different ways to plug this in. You can either say 135 plus 139 and then hit enter and then say divided by 2. And also you'll notice that when I hit the divided by, it said, well, what do you want to divide by 2? I assume you want to divide the answer that you previously had by 2. All right. And then I get 137. So real quick, that's the midpoint of the first class is 137. Okay, but another way that I could do this is I could say, well, I want to do that all at once. I'm going to put in parentheses what I have in the numerator here, 135 plus 139, close parentheses, and divided by 2. Now I'm still getting the same answer of 137. What you cannot do is say 135 plus 139 divided by 2, because order of operations says that the calculator is going to do this division before it does that addition. And sure enough, we get a completely different number if we plug it in like that. So just be really careful when you're using your calculator that either you do it in 2 steps, like we did here, or if you want to do it in 1 step, that you put your numerator in parentheses, but don't do it the way that we did in this last step. Okay. All right, so we found the midpoint of the first class. Now, they didn't ask for it, but if they wanted us to find all of the midpoints, which is really common, right? A lot of times they'll have like a whole column for the midpoints, and they'll ask us to find all the midpoints. So the midpoint of the first class is 137. So if they were to say, we're not going to do it for all of them, but if they were to say find the midpoint for all of them, to get from one midpoint to the next, you could either do the same thing that we did to the first class, you could do that to the second class, or since we already found our class width, we could just add our class width to every midpoint to get the next one, right? So we could do that as well. We'll do that on plenty of other problems, so I'm not going to do it here. Okay, the class boundaries. Okay, so remember when we said that the classes themselves do not overlap? So the class boundaries, they separate the classes without gaps. Separate the classes without gaps, because you'll notice there is a gap. 139 to 140, well, there's all sorts of decimals in between 139 and 140. There's a gap between these two numbers. There's a gap between these two numbers. There's a gap between these two numbers. When I go from this class to the next class, there's a gap. So the boundaries are the numbers that are exactly halfway between your upper class limit of one class and your lower class limit of the next class, such that there is no gap. Okay, so just to kind of, I'm going to give myself a little bit more room to like draw this out here. So we're talking about what do I have, or sorry, when we were talking about the class width, we were dealing with these two numbers, right? Well, now that we're talking about class boundaries, we're dealing with these two numbers, right? So from here to here. So not from here to here, but from here to here. So what's the number that's halfway in between here and here? Now, you might be able to do that in your head. Some of these might be kind of intuitive, but if it's not, that's totally fine. You're going to do the same process for finding the boundary as you did for the class, except instead of using the lower class limit and the upper class limit, you're using the upper class limit and the next lower class limit, right? So we're going to say 139 plus 140 divided by 2. And when you plug that into the calculator, you're going to get 139.5. So what that ends up looking like is if you were to, and I'm going to kind of write a couple of these out here. We would say, okay, the boundary up here is 139.5. So it's exactly the same down here. Okay. So just like I could add the class width to my midpoints, I can also add the class width to my boundary. Okay, so to get from here to here, I'm going to add 5. So another quick thing in the calculator that I want to show you. So if I say 139.5 plus 5, okay, I'm going to get 144.5. I'm trying to write the boundaries just a little bit lower. If I know this boundary, I can write it here because it's the same on each side. And then just like before, I can say plus 5. So I get 149.5. Here, let me actually finish these classes. Okay. And then I can add 5 again. And I get 154.5. Oh, I'm sorry, I didn't finish writing it down here. Whatever the boundary is over here, it's the same over here because there's no gaps, right? So if you do the same thing on your calculator enough times, the calculator is it's gonna figure out your pattern and you can just hit enter. So I didn't hit plus 5, I just hit enter and it said, oh, you must be trying to do the same thing that you've done the last 3 times in a row. You must be trying to add 5. So I can just hit enter to get 159.5. And again, this boundary is the same as this boundary. Okay, now we do still need to have this boundary, and there's no boundary up here for me to look at to determine what this is. So what I have to do is I have to say, okay, well, let's look at each of these. How far away is this from this? This is 0.5 less than this is. So this boundary needs to be 0.5 less than what this is. So that's going to be 134.5. Or another way to do it is to, again, use our class width, right? Class width is super useful. It helps us with all sorts of things because I can say, just like I can add 5 to get down to the next one, I can also subtract 5, right? I can say 139.5 minus 5, and that's going to give me 134.5. So I've got my upper class and lower class limits, and then I have my boundaries outside of them, right? And the boundaries leave no gaps. Okay. All right. So, and they actually just wanted the class boundaries of the first class. So we found that, the 134.5 and the 139.5. So that's how we get A. So quick test taking strategy, when you are looking at a multiple choice problem, you find your class width. If you feel really confident about, I know that that's my class width, you can say, all right, well, already I can narrow down that it's not going to be those two because they have class widths of 4. So I know it's going to be one of these. So then, you look to B and C. Sometimes you can save yourself time by kind of narrowing your answers down that way, especially if you're feeling unsure of a problem. You can at least try and narrow down your options. So, all right, moving on. What are some benefits of representing data sets using frequency distributions? What are some benefits of using graphs of frequency distributions? So, I mean, it answers itself right there. Organizing the data into a frequency distribution can make patterns within the data more evident. If I just give you a whole long list of numbers, it can be a little overwhelming. It's like, okay, great. I've got 30 numbers. What am I supposed to do with that? It's kind of hard to see what's going on with it. But if you organize it into a frequency distribution, and then better yet, if you graph the frequency distribution, then it can be easier to see those patterns, right? So that's what this is asking. What are the benefits of the graph? Same type of thing. It's easier to identify the patterns looking at the graph. Now you can still see some patterns looking at a frequency distribution, but graphs are also another way to see that. Okay. Determine whether the statement is true or false. If it is false, rewrite it as a true statement. The difference between two consecutive midpoints is equal to the class width. So yes, that is true. We were doing that a bunch in the last problem, right? We were adding the class width to get from one midpoint to the next. Well, we didn't actually finish that, but we talked about that, right? We talked about that if I wanted to go from one midpoint to the next, I could add my class width. So class width gets me from one midpoint to the next. It gets me from one lower class limit to the next. It gets me from one upper class limit to the next. And it gets me from a lower class boundary and an upper class boundary to the next. So class width, super useful. Statement is true. The midpoint is the sum of the lower and upper limits of the class divided by 2. Right? We did that. We took the average of them, added them up, divided by 2. The distance between two consecutive lower or upper class limits is the class width. So we already did that. They're just saying it in words. Okay, use the given frequency distribution to find class width, class midpoints, class boundaries. So exact same process that we did last time, right? So class width, we say, what did I have to add to this to get to this? Well, I had to add 3, but if I'm having trouble seeing that, maybe they give me weird decimals or something, don't forget you can always, is the light on? Sorry, I'm trying to see if the light is on. Oh, there we go. Okay, that might help a little bit. Felt like the screen was kind of dark. Okay, so yeah, so if maybe you can't necessarily do this in your head and you want to, figure it out mathematically, you just take the lower class limit of whichever higher class you're looking at, and from it, you subtract the lower class limit of the other one. Right? Or we could have done that to any of these, right? Like, oh, 54 minus 51. That's still going to get me 3. Okay, so we got our class width is 3. And then our class midpoints. So this time they want all of our class midpoints. I shouldn't have written that there because I want to write my midpoints over on the left here. So I'm going to make a column here for my midpoints. Okay, so again, how do we find the midpoints? We add these up, divide by 2, or if you can just see that the number that's directly in between 40 and 2, I'm sorry, 40 and 42 is 41, then that's great. But if not, no worries. You just add them up and divide by 2. Again, make sure if you're going to do that all at once in the calculator that you use parentheses, right? 40 plus 42 divided by 2. Or we can do 40 plus 42, enter, and then divided by 2. Whoops. Oh, no, I'm good. I was looking at the wrong number there. So either way, you're going to get 41. And then again, I could do the exact same thing for every single one of these classes, right? I could write this off to the side. I could say, add them up, divide by 2, add them up, divide by 2, add them up, divide by 2. But that's more work than I want to do. And a lot of what we do in stats is saying, well, how can I do this but faster? So that's what we're going to do. We're going to do that but faster. We're just going to add the class width to this midpoint to get the next class width, or the next class midpoint. So we're going to add 3. So that's going to be 44. And then we're going to add 3, and we're going to get 47. We're going to add 3, so on and so forth. Now, when you do this, you want to make sure that you're just kind of double checking yourself and you're looking at your classes and you're saying, does it make sense that 44 is the midpoint of 43 and 45? Yeah, that makes sense. If I had added wrong, let's say I just did my mental math wrong and I had 45 here. If I looked at this and I said, okay, would 45 make sense? I'd be like, oh shoot, no, 45 is my upper class limit. My upper class limit's not going to be my midpoint. I must have added wrong. And you can go back in and you can, adjust from there. So every step of the way, you're kind of checking yourself, making sure that that what you're doing makes sense. And then they also want the class boundaries. So again, we're going to do this the same way that we did in that other problem, where we're going to say, okay, how do I get, or not how do I get, but what is the number? Well, let's do this one because I don't already have an arrow there. That's halfway between here and here. So again, you can kind of do that in your head. You can say 45 to 46, what's halfway between there? That's going to be 45.5. Or if you don't feel comfortable doing that, or you just want to double check yourself, you add them up and divide by 2, just like we did when we were finding the midpoint, except instead of doing from lower to upper, we're doing from one class to the next class, right? So not in the same class, but to the next class, to the next class, to the next class, however you want to do that. Like what I mean by that is whichever class you want to do, you're going to get the same answer. Right, so there we go, 45.5. Okay, so I have 45.5. So if that's the boundary here, it's also going to be the boundary here. Now I'm going to erase this +3 because I want to leave room for me to do all of the other boundaries because they want all of them. So again, I could say 48 plus 49 divided by 2, and then that number goes there and there. Or we know the class width. So just like we've done many times already, we're just going to add the class width or subtract the class width to get the next boundary, right? So 45.5, that's going to be 48.5. So let's plug this in. Let's do this whole thing first before we do that. So we've got 45.5, and show the whole thing, plus 5, okay? Oh, I'm sorry, it's not 5, it's 3. Sorry about that. 45.5 plus 3 is the 48.5, okay? And then I'm going to add 3 again to get 51.5. And then I'm going to add 3 again to get 54.5. And by this time, my calculator knows what I'm doing. They see the pattern, and I'm going to hit enter, and it's just going to add 3. So I get 57.5, and enter, I get 60.5. So this boundary is going to be the same as this boundary, so I don't have to do any math for that. This boundary is going to be the same as this one, right? So I can keep doing that. Can keep doing that. So here I'm going to subtract my class width. So 45.5 minus 3. So if I know this boundary, it's going to be the same as this boundary. And again, I'm going to subtract 3 because the class width is what gets me from one boundary to the next or one class to the next. Okay. And then I guess the answers are, oh yeah, here they are. The answers are on this next page here. So let's see, what's a good way to display this? Well, you can see that they created the column for the midpoints. So this is a fill in the blank question. And then they want, so you can see here they're saying for this class, the boundary on this side is 39.5, the boundary on this side is 42.5. So you have to fill in both of those. The boundary over here and the boundary over here is 42.5 and 45.5. Right, so you go through and fill those in that way. Okay. All right. Use the frequency distribution shown below to construct an expanded frequency distribution. So they've got several things that they're asking us here, right? So the midpoint, we've done this, what, 3 times now? So hopefully you guys should feel a little bit more comfortable with that. To find the midpoint, we take our lower class limit plus our upper class limit and divide by 2. You could plug that into the calculator if you wanted to, or you could just say, what's the number that's halfway in between 20 and 30? It's going to be 25. To get from one midpoint to the next, we add our class width. They didn't specifically ask for the class width, but we could find it by saying, how do I get one? But we could find it by saying, how do I get from 20 to 31? So we do 20. Sorry, where's my eraser here? So we say 31 minus 20 is going to give us 11. So I need to add 11. I need to add my class width to get to the next midpoint. Or you could take the long way and you could say 31 plus 41 divided by 2 is this. 42 plus 52 divided by 2 is this. 53 plus 63 divided by 2 is this, and so on and so forth. But it's going to be faster to add your class width. Okay, so then the next thing it wants us to find is the relative frequency. So your relative frequency is going to be the, oh, and I shouldn't have written that right there because I need to write something there. It's going to be the part over the whole, okay? So relative frequency, so we're going to be looking at the frequency, and we're going to say, what is the frequency of this particular class as compared to the total number of frequencies that I have? So we want to make sure that we're getting familiar with some symbols and some terminology that we're going to be using throughout this course. So we're going to find the sum of the frequencies. So this is a capital sigma. It means sum. So you add them all together. So if I were to add all of those frequencies together, I would get 365. I did not do that in my head. I did that previously. I already have that number written down. Don't think I can work that fast. So if you add all of these up together, you're going to get 365. So what that means for each of these is we say, okay, well, the frequency for this first class is 17. So I'm going to do 17 over 365, right? The part over the whole. The frequency for the specific class divided by the total frequency of all of the classes. Okay, and then they're saying to round to the nearest hundredth as needed. So quick note about rounding. So we have 17 over 365. We get 0.0465753425. Quick reminder about rounding. So they want to go to the hundredth. So this is the hundredth. We underline the place that they want us to round to. We look to the right of the number that we're rounding to. We say, is this 5 or more? If it is, this number goes up 1. If it's not, this number stays the same. This is 5 or more, so this is going to go up 1. So it goes to 0.05. Quick refresher on that. So, and that's what we're going to do for all of these. So the frequency of this class is 44. So we're going to take that and divide it by 365. Right? We have the part over the whole. So again, 44 over 365, and we get 0.12. So I'm not going to go through and plug those in for all of these, but you can go through and you can check if you do the part over the whole. So this would be 68 over 365, 69 over 365, so on and so forth, right? Okay, and then the last thing it's asking for here is the cumulative frequency. So for your first class, your cumulative frequency is just whatever your frequency is. The frequency is 17, so that's the frequency. For the next class, what you have to do is you have to take the frequency of that class and add it to the one above. So you're going to go 44 plus 17, and that's how we're going to get 61. For the next class, you're going to follow that same pattern. You're going to take your frequency for that class, and you're going to add it up with all of the frequencies that came before it. Okay, so 17 plus 44 plus 68, that gives me 129. For the next one, we say, okay, here's my class frequency. I'm going to take that and add it to all of the frequencies that came before. So when you're plugging this into your calculator, instead of going through, like when I'm here at this class, instead of going, okay, 69 plus 68 plus 44 plus 17, okay, that's 198. Instead of doing that, so, well, let's go through and do this in order. Okay, so to get this one, I did 44 plus 17. Okay, that gives me 61. Now when I go to find the next one, instead of doing 68 plus 44 plus 17, I already know what 44 plus 17 is. It's already stored. All right, there we go. It's already stored here in my calculator. So really all I have to do is say plus 68 to get the 129. And then here, all I really have to do is say plus 69, whoops, 69 to get the 198. And all I have to do here is say plus 77 to get the 275. And all I have to do here is say plus 68, so on and so forth. You get the pattern here, as opposed to having to, like for the last one, instead of having to go 22 plus 68 plus 77 and actually type all of these in, if you're doing them all at once in the calculator, you already have the last number there, right? And you can just add what that frequency is to get the next one. Okay. All right. A misleading graph is a statistical graph that is not drawn appropriately. This type of graph can misrepresent data and lead to false conclusions. This is very, very common in, popular media and quote unquote news and all that. So that's one of the reasons that understanding statistics is so important to being an informed citizen, because whether it's, a company trying to sell you something or whatever, they can very easily create a misleading graph. Okay, so they want us to explain why this particular graph is misleading and then to redraw it so that it's not misleading. Okay, so the first thing about this graph that I want to point out, you guys learned about a lot of different types of graphs and charts and all sorts of things, right? There's a ton of them. This particular one is called a Pareto chart. Pareto, I think it's Pareto chart. So in a Pareto chart, you arrange the columns in decreasing order from left to right. Okay, that's one of the characteristics of a Pareto chart, is that you specifically arrange it, regardless of which quarter you're looking at the sales, you specifically arrange them from highest to lowest, because that's a characteristic of this chart, is to say, hey, we want to look at the highest thing first, and then we want to go down from there. Okay, some people might look at this, and then if they didn't know what the characteristics of a Pareto chart were, they might say, oh, well, this is misleading because they put them in the wrong order. Well, no, that's a feature, not a bug. Okay, so knowing what a Pareto chart is supposed to be can help you get this question right. Okay, but there's still something wrong with it, right? So what's wrong with it? This says 90, this says 130. There is a large gap in the vertical axis, right? We didn't start at 0 and then say, okay, here's 90 and here's 130. No, we just said, okay, forget about all this. We're only looking at this part of the graph, right? We're zooming in and we're taking just a little snippet of just this top part of the graph. Well, if we were to zoom out and look at the whole graph, it's going to look like this. All right, let me make sure we can see both of these at the same time. This looks very different from this. This looks like there is a significant difference between the third quarter and the fourth quarter, right? The fourth quarter is barely anything compared to the sales in the third quarter. But if we look at it with the correct vertical axis, right, showing the whole from all the way from 0 to 130, you can see that, okay, yeah, there is a difference. Absolutely, there's a difference. But it's not nearly as significant as this one. If we were looking here, you might say, oh, well, the third quarter is, let's see, 1, 2. You could say that this looks like it's 4 times as big as that. If you were just glancing at this and you didn't notice this 90 to 130, you might say that the third quarter, you did 4 times as many or 4 times as much in sales as the fourth quarter, which is not at all true, because this is what's actually happening. Okay, so the large gap in the vertical axis makes it appear that the sales for the third quarter are disproportionately larger than the other quarters, when really, yeah, they're larger, but not disproportionately larger. Okay. All right, the top 14 speeds in miles per hour for professional drag racing over the past 2 decades are listed below. Find the median speed. Okay, so let's talk about some definitions here. So mean, remember that's your sample mean is x bar, your population mean is mu. The mean is the average. You add them up, you divide by how many you had, right? That's the mean. The median is the number in the middle. Oh, my M looks funny there. If you get confused about which one's the mean and which one's the median, when you think of median, think of when you're driving and there's that strip of grass in between the northbound and the southbound lanes. That's the median, right? It's the thing in the middle of the road is the median, okay? Now, when we're finding median, if you have just a few numbers, it can be fairly easy. But if you have a lot of numbers, you need to make sure that you know how to mathematically find the median, okay? So the first thing that you're going to have to do is you're going to have to put your numbers in order, okay? So we're going to go through how to do that in the calculator. So something that you guys have been doing in this section or these 2 chapters is you've been plugging things into the calculator. So just to review, if I have a list of numbers that I want to plug into the calculator to have the calculator do some stuff with, I'm going to go to stat, right? So I'm going to hit stat right here. And then I'm going to go to edit. That's number 1, edit. Okay, so it's in this edit tab and it's the first one there is edit. Okay, now I've already pre-plugged in a whole bunch of things into a whole bunch of different lists so that I don't have to waste time plugging them in while we're going through stuff. And for this one, I plugged these things into L1. So I'm going to arrow all the way over to L1. So what I've done is I've gone through and I've plugged all of these numbers into list 1. So a couple things I want to point out. If ever you have things in a list and you don't want them to be there anymore, you want to clear your list, if you arrow up to the top, so you're highlighting the name of the list, so see how L1 is darker, and then you hit clear and then enter, it will clear the whole list, okay? Another thing is that as you're going down, so I hit the down arrow to keep going down, whoops, if I'm on my last number, you can see down here that this says L1 because I'm in list 1, and then it's got a number 14. It's telling me that I am at the 14th number in this list. So that's one way that you can kind of check yourself and make sure that you didn't like accidentally skip a number, right? They told me that the top 14 speeds are listed, so I need to make sure that I've actually plugged in 14 numbers. Sometimes I go to plug them in and I accidentally only plug in 13 because I've missed one, right? You can double check yourself here, make sure that you have all 14 numbers. Okay, so I have all of these numbers in L1 because I went to Stat, Edit, and then I plugged them in. You don't have to have plugged them into L1. You can plug them into whichever list you want. You just need to make sure that you've remembered which list you're in. So we're in L1. So the next thing I want to do is I want to arrange these in order. Oh, by the way, I should preface this with I'm going to tell you how to do this by hand, and then I'm also going to tell you how you can have the calculator do this for you. Okay. So we're going to go back to Stat, and you'll notice under Edit, we have Sort A and Sort D. Number 2, Sort A is sort ascending as opposed to sort descending. So I'm going to go ahead and I'm going to arrow down to number 2 and I'm going to hit enter, or I could just hit number 2. Like if I was back up here, I could just hit the number 2 and it would select it. So I'm going to arrow down to sort A and hit enter. And it says, okay, what do you want to sort in ascending order? And I have to tell it L1. So on your calculator, L1 is down here above the number 1 button. Okay, so kind of like a shift button, you have to hit second. Right? So we're going to hit second 1, and it's going to do L1. You can see it did L1 here. I like to close my parentheses, but you're not required to do that for this particular one. And then you hit enter, and the calculator says, okay, all done. So now we're going to go look at what it did. We're going to go back to Stat, and we're going to go back to Edit to look at the list that it just put in order. Okay? All right, so I'm trying to find my median. Well, how do I know which of these numbers is the median? I got 14 numbers here. Is it the 7th, the 8th, the 6th? How do I know which one it is? So this is where you do an easier problem and then apply that thinking to the more difficult problem. So if I have 5 numbers, I'm going to use my hand. I have 5 numbers, and I want to find the median. Well, looking at my hand, I can see that my middle finger is going to be the median, right? It's this one right here. It's the 3rd. That's the one that's directly in the middle. Okay, but mathematically, how did I get 3 from 5? So if I have, so we're doing median here. If I have an odd number, or if my n, so this is another term you guys are going to need to know, right? N is your sample size. If your n is odd, then what you're going to do is you're going to say, okay, mathematically, how do I get 3 if I started with 5? If I cut 5 in half, that's going to give me 2.5. Sorry, you can't really see that. If I cut 5 in half, that's going to give me 2.5. Well, that's not where I want to be. I want to be the next number up. So you're going to take your n, you're going to cut it in half, and then you're going to go up to the next whole number. All right, take care, Camry, and yes, I will send you the link so that you can look at the rest of this later. All right. So for the odd number, when n is odd, we're going to divide by 2, then go up to next digit, the next number. Okay. All right, well, what if we have an even number, or n is even. Okay, so if I have 4 terms, well, the median is going to be directly in between the 2 and the 3. But yes, Rosa, yeah. So I will, if you either email me your email directly, higher up in the chat, I provided my email. So you can either email me directly or you can type your email into the chat, and I will send a link to the recording to everyone whose email I have. And then, yeah, you can review it later. So yeah, so if I have 4, I need to get to 2.5. Okay, mathematically, how do I do that? Well, if I take 4 and I cut it in half, I'm getting 2. So what I need to do is I need to take the average of that number and the number above it. Okay, so for when it's even, we're going to start the same as when it's odd. We're going to divide by 2. Okay, and then we're going to take the average of that number and the next one up, the next number up. Okay, so what do we have here? We have 14. We have an n of 14. N is 14. So, okay, yeah, so n is 14. So 14 is an even number. So what we're going to do is we're going to take 14 and we're going to divide it by 2. Okay, when I do that, I get 7. So what I need to do is I need to take the average of the 7th number and the 8th number. So I'm going to find the 7th number and the 8th number, and I'm going to take the average of those. I'm going to divide them by 2. Okay, so that's why we needed to put this in order, because I need to know what is the 7th and the 8th number. And just looking at this list, I can't just say, oh, 1, 2, 3, 4, 5, 6, 7, because they're not in order. So you have to put them in order first if you're going to do it by hand this way. Okay. Yes, Taylor. Okay, and you've got your email there. So yes, I will email that to you. Okay, so we're going to quick little calculator thing. If you want to get out of whatever menu you're in, you want to quit that menu. So quit is right above mode. So you do second mode and it takes you to your, I think of this as like the home screen. Okay, also I like to clear, sorry, clear is right here. I like to clear my screen periodically, just nice, fresh, clear screen. Okay, so I'm going to take my 7th and my 8th numbers and divide by 2. And actually, I just realized I needed to go back into that menu because I need to find what is my 7th and what is my 8th. So I'm going to go back to stat. I'm going to go back to edit. If you were already here, then that's great. And I'm going to arrow down to the 7th. So this is another instance where looking at these numbers down here can be helpful, especially if you've got a really long list. Because like if I'm arrowing down and I lose count, that can be a problem, right? So, okay, so my 7th number, because it's telling me the 7th digit in L1 is 196. Okay, so that's 196. The 8th digit is 196.2. So I need to add those together and divide by 2. So I'm going to second quit. And if you can do this in your head, that's great. If you can't, just make sure that you're either doing it in 2 steps like this, or if you're going to do it in 1 step, make sure you have your parentheses. Okay, and either way, you're getting 196.1, which is what the median is. Okay, so that's how to do it by hand. What if we don't want to do all that work? If we want to have the calculator tell us what the median is, we can do that. So, and we're going to do more problems concerning things like the median and the quartiles and stuff later on. We're on number 19 out of 36, so we still have a few problems to get through. But the way that we're going to do those is we're going to go, so this is one option. Another option is, okay, you start out the same, where you put your numbers in. Okay, stat, edit, I put all of my numbers into L1. And then what I'm going to do is I'm going to have my calculator calculate a bunch of stuff for me. So I'm going to go to Stat. Then I'm going to arrow over to Calc. Okay, and I'm going to do the very first option there is one var stats, one variable statistics. Okay, now here you want to make sure that you're plugging in the right thing, that you want the calculator to calculate specifically what you're wanting it to look at. Okay, so I put all of these numbers into list one. So the list is going to be L1. So again, just like we did before, I'm going to hit second one to have L1 there. And then the frequency list, this is not a problem where I had a frequency, right? This is what we call like the raw data. Okay, this is the original data. I didn't take this data and put it into a frequency distribution and get midpoints, right? If I have a list and a frequency list, it's because I have the list is my midpoints and my frequency list is my frequencies. But if I just have raw data, there is no frequency list. It's just the original data in one list. So I need to make sure that I have nothing listed for frequency list because the original data itself is what's in L1. And that's all we're looking at. Okay, so just make sure that you understand the difference there. And I'm going to have it calculate. Okay, so it's calculated a bunch of stuff here, right? So there are going to be other problems where we're going to look at a bunch of stuff here. But for right now, I'm going to arrow down, and right there, it tells me my median, MED, that's median, 196.1. Okay, so if you do it by hand, I mean, you're still using the calculator to put it in order, but then, and then you might be using the calculator to like add things together and divide, but you are calculating it yourself. Or you can have the calculator do it for you, like the whole thing. You still got to put the numbers in, but it's telling you what the median is. Whichever way you do it, you're going to get the same answer. Okay. All right. So number 20, determine whether the approximate shape of the distribution in the histogram is symmetric, uniform, skewed left, skewed right, or none of these. Okay, so let's talk about what those different things are. So if I have something that is skewed left, I have a tail that goes to the left. So I think of this as like, where's the mountain part and then where's the tail part? The tail is to the left. A lot of people get confused and they think, well, where is it highest? It's not where it's highest, it's where the tail is. The tail is, maybe you can think of it as like an arrow. The arrow is pointing to the left. That's left skewed. Whereas if I have something that looks like that, it's pointing to the right, it's right skewed. And these are approximate, right? Because nothing's going to be exactly, kind of curved exactly like that. If I were to draw like a curve kind of approximating this, it would look something like that. That's left skewed, okay? But let's talk about these other things as well, because you're going to need to know them as well. So we just did skewed left, we did skewed right. Okay, uniform. So uniform is when they are all exactly the same, right? So they're all the same height or pretty close to exactly. They don't need to be actually exact, but almost exact. So it kind of gives you like a rectangle, right? So if all of these were things, they would look like that, right? Versus like, maybe you have your, wow, my rectangles look kind of funny. An artist, I am not. Right, so your rectangles would be almost all the exact same height. Okay, so that's uniform. And then symmetric. So symmetric can look a lot of different ways, but essentially symmetric means if you were to like cut it in half or like hold up a mirror in the middle, that both sides are pretty much mirror images of each other. So if I draw a line there, this half looks almost exactly the same as that half, right? That's symmetric. But there's lots of ways you can look symmetric, right? So you can have like, you could have something like this, right? That's symmetric. Or you could have something like that. That is also symmetric. So quick note here, uniform also is symmetric Because if I were to draw a line right in the middle, the left and the right sides would look the same. So a uniform distribution is both uniform and symmetric. Just a interesting little tidbit there. I don't think they really test you on that. So lots of different ways to look symmetric, only one way to look uniform, and then your left and right skewed. Don't forget, it's where is your tail? Where is the, you can think of it as like there's an arrow pointing to the left, there's an arrow pointing to the right. Okay. All right. Okay, approximate the mean of the grouped data, round to the nearest whole number. Okay, so a few things to point out about this. They're saying to approximate the mean, not calculate the mean, but approximate the mean. And the reason for that is because this is not our original data set, right? We were talking about this a little bit just a minute ago, where if I have my original data, it's just a list of numbers, right? It's the original sort of raw data. But I can take that data and I can create a frequency distribution table. But I am losing some information about the original data set when I do that. So anything I calculate from this is going to be off a little bit. It's going to be approximately what I'm looking for, but it's not going to be exactly what I'm looking for, because if all I have is this, let's look at this first class here. This is saying that I have 9 data points that fall within this class, okay? Well, that could look a ton of different ways, right? I could have 9 data points that are all 135. Or maybe all 9 data points are all 139. Or maybe all 9 are exactly in the middle. Or maybe the 9 of them are like kind of evenly dispersed throughout. Or maybe most of them fall closer to 139, but then I've got, or I'm sorry, 135, but then one of them is 139. There's all sorts of different ways that these 9 data points can be sort of distributed throughout this class. And I don't know how they are set apart, right? That's what happens when you've got your frequency distribution table, is you don't have all of your information for your raw data. And that is why we are approximating the mean rather than finding the exact mean. Okay, so how do we actually do this? So the first thing we have to do is we have to find our midpoints, because what we're going to do is we're going to put our midpoints in L1 and we're going to put our frequency in L2. Okay, so we did a bunch of problems at the beginning where we were finding our midpoints. Okay, so we have I'm just going to kind of fly through this part because we've done a few of them before. 135 plus 139 divided by 2, that's going to give me 137. Okay, that's the midpoint of my first class. Real quick, I'm going to say, how did I get from here to here? I had to add 5, so that's my class width. So I'm going to use my class width to find every other midpoint. Okay, so 137 plus 5, whoops, 137 plus 5, 142, and then I'm going to say again just plus 5, and then if I just hit enter, it's just going to continue to add 5 without me having to say plus 5. And again, we want to just kind of do a quick double check, do a logic check. Is it logical that this number is the midpoint of this class? Yeah, that makes sense. 152 is between 150 and 154. Okay, so I often say, like, I have fat fingers. I accidentally type the wrong thing a lot of times. So I have to kind of check myself and make sure that I didn't get an answer that doesn't make sense. Okay, so I've got my midpoints and I've got my frequency. What I'm going to do is I am going to plug this into the calculator and have it calculate the mean for me. Now, you guys have been taught how to do this by hand, which is great. It's important to know that there are formulas and how to use the formulas. But at the end of the day, when you go to take the test, your instructor is not expecting you to do these types of problems by hand. They're expecting you to know that a formula exists, but to learn to use the technology to find the information faster. Okay, so it's important that you know the formula, because they want you to know, hey, there is a formula, right? This isn't just magic. The calculator is not just magically coming up with something. It's using a formula, and we can do that formula on our own. And before calculators were invented, we did. But now that we have this technology, part of the learning that you do in this class is learning how to use the technology, okay? So we're going to do this in the calculator. So we're going to go Stat, and we're going to go Edit, and we're going to plug in L1. So we're going to plug the midpoints into L1, and we're going to plug the frequency into L2. Now, I did this in L2 and L3 because, like I said, ahead of time I plugged everything into my lists here so that I wouldn't have to take the time to plug it in while we were going through the problems. So you're probably going to have L1 and L2. I'm going to have L2 and L3, but it's the same process, okay? So I've got my midpoints here in L2, and I've got my frequencies here in L3. Okay, so we plug that in after we went to Stat Edit. Now we're going to go to Stat, and instead of Edit, we're going to arrow over to Calc, and we're going to do number 1, which is 1 var stats. Okay, and we're going to have to tell it that my list, and I didn't write this down last time, but my list is, in my case, it's L2, and my frequency list is L3. My pencil lead often breaks because I like to have the 0.5, which is thinner, but it means it's also more susceptible to breaking. All right, so I have L1, or I'm sorry, in mine, I have L2. So again, quick reminder, L2 is right here above the number 2. So I'm going to hit second because it's kind of like a shift button, right? Shift 2 is L2. I'm going to arrow down and do second 3. And that's how I get L2 and L3. Okay, and then calculate. So again, just like the other one that we did, it's going to give us a bunch of stuff, but what are we looking for? We're looking for the mean, okay? And the first thing that it gives us here is the X bar, the mean, the 147.952381. Now you'll notice that exact number is not here because they want us to round to the nearest whole number. So again, quick reminder, how we round, 147.952381. They want us to round to the nearest whole number. We underline the number we're rounding to. We look to the number to the right. If that number is 5 or more, our underlined number goes up 1. If this number is not 5 or more, so if it's 4 or less, this number stays the same. Because this is 5 or more, this number goes up 1. It goes up to 148. Okay? All right. Number 22, determine whether the following statement is true or false. If it's false, rewrite it as a true statement. The mean is a measure of central tendency most likely to be affected by an outlier. That is a true statement. So they talked a little bit about outliers in these chapters. I think one of the examples they gave was like, maybe you have like a list of an example they often like to give is like the list of ages in a college class. So you might have like 18, 19, 20, 21, 22, 23, 24, and then you're going to have a 45, and you might have a 64. I always thought those were kind of interesting because here at Daytona State, we get a lot of people that are not 18 to 24 taking classes. A very good portion of our student population is much older than that. But anyway, so an outlier would be if you have a whole bunch of 18 to 24-year-olds and then you've got one person who's 50, they're the outlier, okay? All right, moving on. Number 23, determine whether the approximate shape of the distribution in the histogram shown is symmetric, uniform, skewed left to right, or none of these, and then justify your answer. So again, we kind of already went over this, right? If I were to sort of sketch this, it would look like that, right? Like it would look something like that. That's an arrow pointing to the right, so that is skewed right. The shape of the distribution is skewed right because the bars have a tail to the right. The tail is over here. So again, it's not where the highest bar is, It's where the tail is. Okay. All right, the number of credits being taken by a sample, 13 full-time college students are listed below. Find a bunch of stuff. Find the mean, the median, the mode of the data, if possible. If any measure cannot be found or does not represent the center of the data, explain why. Okay, so I didn't really talk about this in the last one, but measures of central tendency, that's the mean, median, and mode, right? Those are our measures of central tendency. Okay, so 13, that's our N. That's our sample size. As you go through this class, you want to kind of get used to labeling the things that it gives you in the problem. So if it gives you a number, say, okay, what symbol represents that number? What did they actually just give me? Because they're going to describe it in words. You need to be able to describe it in symbols so that if you're going to be using a formula, you can easily plug that in. Okay, so they want us to find a bunch of stuff. Let's have our calculator find that, right? So for this one, I plugged this into L4. So again, I'm not going to write this down, but you're going to go stat, edit, and you're going to plug in all your numbers into some list that you're keeping track of which list it is. You can plug it into any of them as long as you know which one you plugged it into. Then you're going to go to stat, calc, one var stats. And for this is a list of numbers, not a frequency distribution. So I do not have anything in my frequency list. My frequency list is blank because this is just one list of numbers. So there's no frequency list, right? Okay, so I'm going to calculate it and it's going to give me a bunch of stuff. So let's pick out some of the stuff that it gave us. So the first thing it gives us is the mean, the X bar. That's 8.2. Okay, great. So then it says, okay, does the mean represent the center of the data? Yeah, the mean represents the center. Measure of central tendency, right? Okay, then the next thing it wants is the median. Okay, so what I'm going to do is I'm going to arrow down, and there it is. There's my median. My median is 8. So does the median represent the center of the data? Yes, it represents the center, right? 8, 8.2. Sorry, you guys can't see that. 8, 8.2. Those are both, they're near each other. Okay, then the next thing that it asks for is the mode. Okay, so what is the mode? The mode is the data point that occurs most often. So, sorry, there we go. The data point that occurs most often. So what happens the most? So if I'm looking at this list, I don't need to put this in order to see that I've got a bunch of 8s, I've got some 11s, and I got a bunch of 7s. So let's just double check and make sure that we really do have more 7s than we do 8s, right? So if I counted the number of 8s I have 1, 2, 3 8s. So the number 8 occurred 3 times, but 7 occurred 1, 2, 3, 4, 5, 6 times. So it occurred the most number of times, so that means 7 is the mode. Okay, if we were to take these numbers and put them in order, 7 is the lowest, right? The lowest number that we have is what occurs the most often. So it occurs a bunch of times, but then everything gets bigger after that. We've got multiple 8s, we've got a 9, we've got a 10, and we've got 2 11s. So 7 might occur the most often, but it's not a measure of the center. It's our minimum value. So let's see, how did they word that? They said the mode, I was like, no, does not. They're just saying because you can have multiple modes. So let me read through that and then I'll talk about that in a second. The mode does not represent the center because it is the smallest data value. Okay, it's not a measure of central tendency in this set because it doesn't give us something near the center of the data, right? We check the mean, median, and mode to see if they are measures of central tendency. And in this case, it is not. The mode is not. Okay, so why do they have an S here? And why are they saying, does versus do? You can say it either way, because you can have more than one mode. Okay, now in this case, we didn't. We just had the one mode. All we had was 7. Yes, 8 occurred more than once, but it occurred fewer times than 7 did. So something that, like, if I were to tweak this data, maybe 10 occurred 1, 2, 3, 4, 5, 6. If 10 occurs the exact same number of times as 7, then we would have 2 modes because they're both occurring the same number of times, and it's the most as compared to all of the other numbers that are occurring. Okay. All right, so again, 7 is the mode, but because it is actually the smallest data value, it's not representative of the center of the data. It's not near the center, so it is not, doesn't represent the center of the data. Okay. All right, 25. The gas mileages in miles per gallon for 30 cars are shown in the frequency distribution. Approximate the mean of the frequency distribution. Again, we're approximating it because we don't have the original data, so we can't find the exact mean, but we can certainly approximate it. So again, I know that I'm going to have to plug this into my calculator, and I say, okay, well, what exactly am I plugging in? I can't plug in 30-35, so what do I have to do? I have to find the midpoints, right? The midpoints are going to be my L1, and my frequencies are going to be my L2, right? So again, finding our midpoints, I say 30 plus 35 divided by 2. That's going to give me 32.5. And then I can add my class width to get to the next one, or I can just do that the same as I did before, 36 plus 41 divided by 2. Or I can say, okay, I'm going to add 6 to get from here to here, so I need to add 6 to get from here to here. So that's going to give me 38.5, and then 4.5, and then 50.5. So again, just kind of rushing through that just so that we can get to actually plugging this in. So this is going to be my L1, and this is going to be my L2. Now, in my calculator, I did L5 and L6, but you would go stat, edit, you would plug it into whichever 2 lists you want, and then you're going to go to the stat calc, one var stats. Your list is your midpoints, right? Again, in my case, I did L5, and your frequency list is your frequency. So again, I did L6, and you calculate, and it gives you your number. Again, your X bar, that is your mean. Okay, number 26, the number of hospital beds in a sample of 20 hospitals. Okay, that's my N. N is 20. Construct a frequency distribution and a frequency histogram for the data set using 5 classes. Describe the shape of the histogram as symmetric, uniform, negatively, positively skewed, or none of these. Okay, so quick note here. They have already told you what your classes are, but if you didn't have that, like if you had to really come up with this from scratch, then what you want to do is you want to start with either your lowest value, or you can start a little bit below your lowest value if you want to. But to determine what your class width should be, we've got a formula for that. Okay, so your class width, you're going to start by doing your range divided by the number of classes that you want. Okay, so remember your range is your max minus your min, your maximum value minus your minimum value. Okay, so here my minimum value is 127. My maximum value is 287. There's a smallish number of numbers to look at here, so you can do that just by looking at them. But if you're having trouble picking out the biggest because you think you might be missing one, go ahead and put them into your L1, L2, whatever, and then sort them. Again, to sort it, you go stat, sort A, and you tell it which list to sort. It does it, then you go back to your list by going stat edit and you look at the list and it's sorted, and you'll be able to see the number at the top is your min, the number at the bottom is your max. Okay, so we're going to do the max minus the min. That's still number of classes down there. So our max is 287, our min is 127, and the number of classes that we want is 5. Right? They said to use 5 classes because for just a minute here, we're pretending like they didn't even give us any of this and that we have to come up with what those numbers are to begin with. Now, when we get this number, we're not keeping this number. We have to go up 1. So if you plug this into the calculator, you're going to get 32. So you have 32 and you have to go up 1 more. You have to go up 1 more. Okay. You guys are probably going to have to do some project at some point in your class where you're going to have to create a frequency distribution on your own from scratch. They're not going to give you this. They're just going to give you the raw data and you have to create it. So make sure that when you're finding the class width, you do the range divided by the number of classes, whatever number you get, go up 1 more. Go up to 33. In this instance, it's 33. Okay. Right, to get from 127 to 160, I had to add 33, not 32. Okay. All right, so let's say we're doing this from scratch. We created our classes, right? We started with 127 and we said, okay, I need to go up 33 to get here. Okay, once I have that, how do I determine what this is? Well, it's just 1 less than this. And then I add 33, add 33, add 33. And once I already have this, again, I can just add 33 every time, or I can say, well, what's 1 less than this? Well, what's 1 less than this to figure out what my upper class limit is? Okay, so what about the frequency? How are we filling this in? Remember, the frequency just represents how many numbers occur in that category. So what you're going to be doing is you're going to be creating tally marks. And then after you do the tally marks, you're going to write it nice and pretty with actual numbers. Okay, so you would go through, I'm not going to do the whole thing, but just to kind of show you, I'm going to say, okay, 168, what category does that fall into? 168 is in this class, right? 168 is between 160 and 192. All right, 160, that's also in this class. 127, that's in this class. 127 is in this class. 182, that's in this class. 163 is in this class. 168, that's in this class. And I mean, you can do it however you want, but with tally marks, when you get to the 5th one, you do a diagonal line. I'm not sure if you guys are familiar with that. Okay, so that was 168. 220, that's going to be in this class. 145, that's going to be here. 134, that's going to be here. And you do the whole thing and you say, okay, now how many tally marks do I have? And then you write them nice and pretty. If I had done the whole thing, we would have had 6 tally marks here, 6, 4, 2, and 2. Okay, so that's how you're creating that from scratch. Okay, and then it also wants us to do a frequency histogram. Okay, so this one is, there we go, is multiple choice, right? So they've created the histograms for you. So one thing that you can do is you can say, okay, well, let me just look at my frequencies, right? Your y-axis, your vertical axis, that's your frequencies. Your horizontal axis is the number of beds, right? That's the number of hospital beds. Don't forget that, this down a little bit. Don't forget that we're not just dealing with random numbers. These represent real things, okay? Everything in stats is a word problem, right? Okay, so we have a frequency of 6. So if I were going like from left to right to try and narrow these down, I would say, oh, well, this says that the first, that my first class has a frequency of 2. So that's out. Okay, this says that my first class has a frequency of 6. Okay, we're good so far. Then my next class is also supposed to have a frequency of 6, but this says that it has a frequency of 4. So that's out. And then let's pretend like these were switched and I was looking at this. Again, we could say this is out because it's saying that the first class has a frequency of 4. It doesn't. It has a frequency of 6. So again, we can double check this. My first rectangle here goes all the way up to 6. So does my second one. Okay, so that's good. That's good. The next one needs to go up to 4. Okay. And then the next two, the last two, need to be at 2. Good and good. Okay. All right, and then it wants us to look at the shape. Describe the shape of the histogram as symmetric, uniform, negatively, positively skewed. Also remember negatively skewed, that's skewed to the left. Positively skewed, that's skewed to the right. Or none of these. So the histogram is positively skewed, right? If I were to draw that, it would look something like that. I have a tail on the right. That's the right, or positive. It's positively skewed because the right tail is longer than the left tail. I don't like thinking about this as a tail. It's just where is the actual tail? To the right. Okay. All right, during a quality assurance check, the actual contents in grams of 6 containers of protein powder were recorded as, and they give us a bunch of numbers here. Okay, find the mean and the median of the contents. Okay, so what we're going to do is we're just going to take that list of numbers and plug it in for L1 or whichever list you're looking at, and we're going to have our calculator calculate that. So in mine, I did it in L7. So you're going to go to Stat, Edit, and whichever list you want, you're going to plug those numbers in. So there's my L7. And then I'm going to have my calculator calculate stuff. So I'm going to go to Stat, I'm going to arrow over to Calc, and I'm going to do the first option, 1var stats. So again, because I have a list of raw data, I only give it that list. Oops. Oh, that's right. This doesn't have L7. Give me just 1 second because I have to go alpha. And then where is L? L7. Okay, and then I clear my frequency list. You guys don't have to do what I just did where I hit the alpha because you guys aren't going to be using that many lists all at once. I'm just doing that because I filled up a whole bunch of lists. Because like down here, you can see that like it stops at L6. So I have to tell it to use the alpha, which is you probably can't see it because of the reflection, but the yellow letters. So this is like a different form of shift, but you guys don't have to worry about that. Okay, but you're going to plug in whichever list it's in. You're going to clear your frequency list because we don't have a frequency distribution here. We just have a raw set of data. Then we go down and we calculate. Okay, so we get our mean. Our mean is 1519.5. Okay, great. But then it says the third value, okay, let's take a look at the third value, was incorrectly measured and is actually 1518. Find the mean and the median of the contents again. So they're saying, okay, we had the list of numbers, we realized one of them was wrong, so now we have an updated list of numbers. So in my calculator, I put that as L8. So again, you would go edit. Now, if you had just plugged this in, you would just arrow down and you would just, instead of 1503, you would type 1518. Now I went through and I just created this in L8, but you could have just gone in and just adjusted the third value. So I'm going to go to Stat. I'm going to have it calculate something, and I'm going to have it do L8 because I created a different list. So now, oops, I must have plugged something in wrong. Let's check that. 1528, 1526, 1518, 1512, 1532, 1516. Oh, no, I was looking at the wrong thing here. I forgot that it also wanted us to find the median, sorry. So I did plug it in correctly. We're good. 1522 is the new one. Okay, the previous one, they also wanted the median. So remember, the median is, you scroll down and it gives you the median right there. So this is the median of the updated set of numbers, okay? Okay, so now it wants us to think critically about those changes that occurred, right? So after correcting the error, the mean increased, right? So originally the mean was, whoops, erase that, where's my eraser? The mean was 1519.5. And when we adjusted the data, when we changed that number, it increased to 1522. The median was 1521. And when we changed that value, it increased to 1522. Okay, so after correcting the error, the mean increased by 2.5, right? To get from here to here, it went up 2.5. Again, if you want to do that in the calculator, you just plug that in, right? You just subtract them, you're going to get 2.5. Whereas the median increased, right? They both increased because this number increased quite significantly, right? 1503 up to 1518, that's a big jump. It increased by 1. So the mean was affected more, right? This was an increase of 2.5. This was an increase of 1. So the mean, this was the change in the mean, this was the change in the median. What they're trying to get you to see here is that the mean is affected more by these. Actually, do they say that in the next question? Okay, they don't. They say that in another one. What's affected more by outliers? But anyway, they're just trying to get you to see that when you change a data value, it's going to change your mean and your median. Okay. All right. The heights in inches of 20 adult males are listed below. Find the range of the data set. So we kind of talked about this a little bit before, right? What's our range? Our range is our maximum value minus our minimum value, right? So we say, okay, what's our maximum value? In this list, it's 74. Our minimum value is 67. If we subtract them, we get 7. Okay. And again, if you can't see that because there's too many numbers and you're like, oh, I think I might be missing one, then you can always go in and plug that into your calculator, into one of your lists, and then go stat sort ascending, tell it which list to sort, look at the first number, and look at the last number. Actually, I think, yeah, I did actually plug this in. So let's go ahead and do that. So stat, edit, I plugged these into L9, right? I just plugged it in the order that it gave it to me. And then I'm going to go to stat, sort ascending, and I have to tell it L9. And it says, oops. Was I in L9? Oh, I was in L9. Okay, maybe it doesn't like it because I created that. Hold on, stat, sort ascending, L9. Okay, I'm not sure why it doesn't like that, but that's okay. So when you sort it, it's going to be the first number in the list is your lowest, your minimum. The last number in the list is your maximum, right? Okay, pretty straightforward. Okay, number 29, find the sample standard deviation, round to the nearest tenth. So we talked about this a little bit before, but don't forget that you have your sample symbols and your population symbols. Right, so for right now, you guys are doing like mean and standard deviation. So the sample mean is that symbol, the population mean is that symbol. The sample standard deviation is S, your population standard deviation is sigma. So this is the Greek letter mu. This is the Greek lowercase sigma, right? Remember earlier we did, that is the capital. So is that with an A or an O? I think it's an A. Capital sigma. Okay, but lowercase sigma is our population standard deviation. So quick note, when you have your calculator calculate things, you'll notice it gives you this symbol, but it doesn't give you this. That's because the formula for these is exactly the same. Exactly the same. But the formula for your sample standard deviation is actually different than the formula for your population standard deviation. So it's going to give you both of these because it doesn't know, the calculator doesn't know whether you just gave it a sample or whether what you gave it was the entire population. So it's going to give you both of those. So you have to know whether to look for the sample symbol or the population symbol. This is telling us that this is a sample. This is not an entire population. This is a sample. So we need to make sure that we're looking at this symbol. Your calculator might show it as an S with a sub X, but that's your sample. So again, you're going to go to Stat, you're going to Edit, you're going to plug your numbers in. I plugged them into L10. You can plug them into whichever list you want. Then you're going to go to Stat, you're going to arrow over to Calc, you're going to go to the first one var stats. You're going to tell it which list to look at. Again, your frequency list you leave blank because there is no frequency. This is not a frequency distribution. This is just the raw data. Well, it's the sample data. And calculate. So the sample standard deviation is going to be, so you're looking at this right here as opposed to this, right? The S as opposed to the sigma. See how they're slightly different, right? So if you round that to the 10th place, you get 4.8. Okay. All right. Okay. The mean length of a human pregnancy is 270 days with a standard deviation of 11 days. Use the empirical rule to determine the percentage of women, empirical rule, whose pregnancies are between 259 and 281 days. Assume the data set has a bell-shaped distribution. Okay, so let's talk about what is the empirical rule. Okay, so we're looking at a standard distribution. Right, you guys have learned about these. We have right in the middle is the mean, and I'm going to use population symbols here. Okay, I can go 1, 2, well, I can go more than 3, but I can go to the right or to the left a certain number of standard deviations. So if I go 1 standard deviation to the right, that's the mean plus a standard deviation. If I go 2 standard deviations to the right, that's the mean plus 2 standard deviations. And if I go 3, that's the mean plus 3 standard deviations. Similarly, I can go in the other direction, and I can say that this is the mean minus a standard deviation, this is the mean minus 2 standard deviations, and this is the mean minus 3 standard deviations. Okay? Okay, so the empirical rule says that the mean is right in the middle, that if I go out 1 standard deviation in both directions, so 1 to the right and 1 to the left, 68% of the data is going to fall right there. It's going to be in this area right here, 68% of the data. And then if I go out 1 more set of parentheses, or I mean, not parentheses, if I go out 1 more standard deviation, so if I go 2 standard deviations to the left and 2 standard deviations to the right of the mean, that's going to be 95% of the data. So 95% of the data occurs within 2 standard deviations of the mean. And then if I go 1 more out in each direction, so 3 standard deviations to the right and to the left, that's going to be 99.7% of the data. So this is called the empirical rule. You might also hear it called the 68, 95, 99.7 rule. But you're going to need to make sure that you have those numbers memorized. Okay. All right. So they're telling us that we have, so let's draw something for this specific set of numbers here. we have a mean of 270. Okay, off to the side, I'm going to write that our standard deviation is 11. Okay, so they're giving us 259 and 281. So 259 is less than 270, right? It's over here to the left. So how far to the left is it? Well, if we say, how many times did I have to subtract 11? So 270 minus 11, if I just go one standard deviation to the left, that is an x value of, whoops, of 259. And 281, so if I'm at the mean of 270 and I add one standard deviation, so I go to the right, one standard deviation, that is an x value, that's a data value of 281. Because I had to add 11 and subtract 11 to get to those two numbers, that is one standard deviation to the right and one standard deviation to the left, right? And what did we say about how much data is between one standard deviation to the right and one standard deviation to the left? It's 68%. Okay. So if they tell you to use the empirical rule, you're probably going to have nice, pretty numbers that align, right? You didn't have to take part of a standard deviation. Okay, for the following data set, approximate. Again, we're approximating the sample standard deviation to the nearest hundredth using the grouped data formulas. So again, we can just use our calculator for this. We are approximating this because we don't have the original raw data. So again, we're going to find our midpoint, and we're going to add the class width to get the next midpoint and the next one and the next one. Our midpoint is going to be our L1. Our frequency is going to be our L2, right? We've done this several times now. Same thing that we've been doing before. So the midpoint is the number exactly between these two, or you can think of it as the average of these. Add them up, divide by 2. And then we say, okay, how did I get from here to here, or what do I have to add to this to get to the next one? That's going to be 3. So I can just add my class width to get the next one, right? So you would continue doing that. I'm not going to actually plug this in just because we're already 45 minutes over and we still have several problems to go. And we've done ones like this several times already, right? You're just plugging this into L1, the midpoints, you're plugging this into L2, and then you're going to go stat calc, and you're going to have it give you the answer. Now, one thing that I do want to make a note of here is they said sample standard deviation. So make sure that you're looking at the S with the sub x as opposed to the sigma with the sub x, because this is your sample value and this is your population value. Okay. All right. The ages in years of a random sample of shoppers at a gaming store are shown. Determine the range, mean, variance, and standard deviation of the sample data set. So again, we're going to take these numbers, plug them into a list, and have our calculator do this for us. Okay, I happened to plug it into L13. So you're going to go stat, edit. Hopefully this is sounding very familiar by now, right? You've done this a million times. So I plugged these in here, and then I'm going to go stat calc, one var stats, and I'm going to do L13. Make sure that nothing is there in your frequency list because this is not a frequency distribution, right? It's different from this one, right? You guys see the difference there? I feel like people get hung up on this, like they get confused as to when they're supposed to have something. If you have a frequency distribution, yes, you've got an L1 and an L2. You need to make sure that you tell it which list is the frequency. But here, we don't have a list of frequencies. This is just the original data. Okay, and we have it calculate a bunch of stuff for us. And let's pick out the things that are nice and easy to find, where we don't have to do any math. So things like the mean, that's the X bar, right? So the mean, that's 17.2. Okay, the standard deviation. So that's our sample standard deviation, right? That's our S sub x. So that is, if we round to 1 decimal place, that's 3.4. Now, you'll notice that it asks for the variance before it asks for the standard deviation. That's because if you were doing this by hand using the formulas, you would end up finding the variance first, and then you would have to take the square root of it to find your standard deviation. But we're not doing it by hand, we're doing it in the calculator. So we actually find our standard deviation first because it calculates your standard deviation for you. What it doesn't calculate for you is your variance. So you have to know that to find your variance, you have to square your standard deviation, okay? So if you take this number, 3.39280284, I'm just going to go 39, and you square it. So in your calculator, it's this button right here, okay, square. And then you round that the way that they tell you to round. That's how you're getting your variance, right? Your variance is square of the standard deviation. Okay, the other thing that we have to do a little bit of work for is the range. So we've talked about this before. The range is the max minus the min. So conveniently, so let me just have it redisplay those numbers. Conveniently, it gives us the min and the max, right? The min is right there, it's 12, okay? And then I can arrow down, and it gives me the max of 23, okay? So we subtract those, and we get 11. Okay, 33. A radio station claims that the amount of advertising per hour of broadcast time has an average of 12 minutes. Let's go through and start labeling things. The average, that's the mean. Average of 12 minutes. And a standard deviation equal to 2.8 minutes. You listen to the radio station for 1 hour at a randomly selected time and carefully observe that the amount of advertising time is equal to 18 minutes. So what they just gave us is an X value, not X bar, but X. That's your data value, is your X. Calculate the Z-score for this amount of advertising time. So remember, what is your Z-score? It's the number of standard deviations you are away from the mean. Okay, so if we were to like draw a picture of what's happening here, okay, my mean is right in the middle. I have a mean of 12. I always like to write off to the side, okay, I got a standard deviation of 2.8. This X is 18. Well, that's to the right. Now, I don't know how far to the right, but it's to the right some amount. What I want to know is how many standard deviations to the right is this X value? Okay, so we have to use a formula, and you guys are going to need to memorize this formula. You're going to use it all throughout the class. This formula is X minus the mean divided by the standard deviation. And again, just like with other things that we've done, if you want to plug this in all at once into the calculator, you need to put that numerator in parentheses, okay? Now, if you're dealing with sample values, then you're looking at your sample symbols. We're dealing with the population symbols here. Okay, so let's plug in what we know. We know our data point is 18, we know our mean is 12, and we know our standard deviation is 2.8. So we're going to plug this into the calculator to get the corresponding Z-score. Move this a little bit here. Right. So we have 18 minus 12 divided by 2.8. And we get 2.14. So this is 2 and a little bit more standard deviations to the right of the mean. So 1, 2, 3, right? If I was to do 1 standard deviation, 2 standard deviations, 3 standard deviations, it's just a little to the right of 2 standard deviations from the mean. And we know it's to the right because it's positive, right? Our Z-score is positive 2.14, but we knew it needed to be positive because we knew 18 was to the right of 12. If we had a number over here, like maybe 10, 10 is to the left of 12, that would have given us a negative z-score, right? Positive z-scores are to the right of the mean, negative z-scores are to the left of the mean. Okay. All right, the weights in pounds of 30 preschool children, n is 30, are listed below. Find the 5-number summary. Okay, so what is the 5-number summary? So if you have all of your data values and you line them up in order, the one at the bottom is going to be your minimum value. The one at the top is going to be your maximum value. And we can divide the numbers into quartiles, okay? The value that separates the bottom quarter from the rest is your first quartile. The value that separates your top quarter from the rest is your third quartile. And the one directly in the center is your second quartile, which is also your median, right? Your median is your second quartile. So to figure these out, we're going to have the calculator do it. If you wanted to do this by hand, you could, but that would take a really long time. So it's still going to take plenty of time to plug all this into the calculator, right? So it's not like we're not doing any work here. So we go stat, edit. I plugged this into L14 and okay, yeah, just making sure I have the right numbers here. And then you're going to go to, same as we've been doing, stat, calc, one variable stats. This is an entire list. There's not a frequency distribution here, so there is no frequency list. I leave that blank. And then we calculate. So down here is where it starts giving us the 5-number summary. Our minimum value is 25. Min X, that's 25. Let me write it up here. Q1, first quartile, it's 28. The median, remember your median is your second quartile, is 30.75. The third quartile is 34. And your maximum value is 38. Okay. So remember, in the calculator, it gives you your 5-number summary all together. So if you're ever unsure, like, wait, what's my second quartile? It's right there where it should be, in between the first and the third quartile. Okay. All right, almost done, guys. Second to last problem. The ages of the winners of a cycling tournament are approximately bell-shaped. The mean age is 28.5 years. Let's go ahead and label that. Mean 28.5 with a standard deviation of 3.3 years. The winner in one recent year was 36 years old. First thing they want us to do, transform the age to a z-score. So our data value was 36. They want to know how many standard deviations from the mean is that data value. That is the z-score. So we are, again, we're going to use that formula, x minus the mean over the standard deviation. So we have 36 minus 28.5 over 3.3. Again, if we plug that into the calculator, we get approximately 2.27 because we're going to 2 decimal places. That's what they told us to round to. Okay, now they want us to interpret that. So again, we can kind of draw our distribution here. We've got a mean of 28.5. We can go 1, 2, 3. We can go as many standard deviations as we want, but most of the time we look at 3 and 3. And this one, this x value of 36 is 2.27 out from the mean. So 1, 2, and then about another quarter. So it's about there. That's about where that data value is. It's got a z-score of 2.27 because we're 2.27 standard deviations to the right of the mean. So the age of 36 is 2.27 standard deviations above, that's weird kind of how they have that written there, above the mean, right? It's to the right of the mean. And we know that it should be because 36 is greater than 28.5. Okay, then they want us to determine whether the age is unusual. So what is usual? Go through a lot of lead here. Okay, let's pretend that that's symmetric. Okay, so let's talk about usual and unusual. Going 2 standard deviations out from the mean, that's usual. But if you go 2 to 3 standard deviations out from the mean in either direction, those are unusual. And then if you go 3 standard deviations out from the mean, that's very unusual. I mean, it's unusual, but even more so. Unusual. Okay. So 2 standard deviations from the mean, you can go out in either direction and it's still usual. But once you pass that 2 mark, you're now considered unusual. Well, this did pass the 2 mark. It's beyond 2 standard deviations from the mean. We went to the right 2 and a little bit more to the right. So yes, the value is unusual. A z-score outside of the range of -2 to 2 is unusual, right? Because we can go negative or we can go positive. But once we go beyond 2 in either direction, +2 or -2, then it's unusual. Okay. All right, last problem. Finally made it. Okay, table shows population statistics for the ages of Best Actor and Best Supporting Actor winners at an award ceremony. Distributions of the ages are approximately bell-shaped. Compare the z-scores for the actors in the following situation. So they want us to find the z-scores for these x values. Right, so we have two different bell curves happening here. We have the Best Actor bell curve, Best Actor, and then we have the bell curve for Best Supporting Actor. Okay, so for the Best Actor, the mean age was 41, and there was a standard deviation of 9.2. For the Best Supporting Actor, the mean age was a bit older, right, 55, and the standard deviation was, whoops, that doesn't look like a standard deviation symbol, that looks like an A. Let's fix that. Standard deviation of 12. So you can see this, the spread is a bit more, right? If my standard deviation is bigger, my data is spread out a bit more. So we've got more spread in the supporting actors versus the Best Actor. Okay, so for Best Actor, in this particular year, their age was actually 40. Well, 40 is less than 41, so we're going to be somewhere to the left, maybe just a little bit to the left, but that x value is 40 because we're to the left of the mean. So let's do this one before we do this one. So we're going to find how many standard deviations to the left of the mean are we? So we're going to do our x minus our mean over our standard deviation. X minus mean over standard deviation. So we plug that into the calculator. And we get -0.11. Again, if you're rounding to 2 decimal places, you get -0.11. So that's not even a full standard deviation to the left. So I drew that way too far over. That's like right there is that x value. It's like 1/10 of a standard deviation. Anyway, this is not to scale. Okay, so it's a little bit to the left, right? Okay, so now we're going to do the same process over here. This year, the Best Supporting Actor was 82. Wow, so that's definitely to the right. We don't know exactly how far to the right, but We know that this X value is 82, and we're going to find its corresponding Z-score by doing X minus the mean over the standard deviation. X is our 82, the mean is 55, and our standard deviation is 12. So that's how we're getting 2.25. So we are 2 2.25 standard deviations to the right of the mean. Okay, so the best actor, this one, they were less than 1 standard deviation below the mean, right? Less than 1 standard deviation below the mean, which is not unusual. Right? We weren't even 1 standard deviation away, let alone more than 2 standard deviations away. We were right near the mean. That's not unusual. But the best supporting actor was more than 2 standard deviations away from the mean, which is unusual. Because remember, anything beyond 2 standard deviations, anything to the right or to the left of 2 standard deviations in either direction is unusual. Okay. Okay. All right. We did it. We got through all of them. So, like I said at the beginning, I am going to be emailing everybody. I'm going to be emailing everybody a link to this recording. Once the recording is ready, it'll be later today. You'll get that email if you provided me your email address either in the chat or if you emailed me directly. You guys have lots of resources available to you as you prepare for your first test. So these reviews and these recordings are one resource. Your instructor is a great resource. The Academic Support Center at whichever campus you're closest to is a great resource. You don't have to make an appointment to go into the ASC. You just show up. We have a bunch of people that can help with statistics. I am not the only one. And when I email this to you, I'll give you information about like what days I'm at what campuses. A lot of us work at multiple campuses. So if you find somebody that you like that explains things in a way that makes sense to you and you want to follow them around from campus to campus, you can do that. So I'll show you how to find where they are on what days and times. But just make sure that you're going through, that you're doing all the homework that's been assigned, and that you are doing the review set of homework, which is the summary of everything that's going to be on the test, which is what we went through today. Again, your questions will be a little bit different from the questions that I had, but they're going to cover the same material. Okay. All right, so I'm going to give everybody just a minute. I see somebody's typing, so I just want to give you guys a second to get that in case you got a question. Oh, you're welcome. Yeah, I will stop the recording in just a second here, and then we'll get this sent out to you guys later today. But I hope this helped, and everybody, good luck on your test. All right, see you later.